I would like to say that we are really honored to have Vibhu Sharma here with us today. Vibhu, who is the CEO of Innovent, which is a technology and consulting company that provides innovative APM solutions, and they have a digital, virtual, intelligent platform and process simulation, automation, and engineering solutions for chemical, pharma, and energy industries. Vibhu Sharma is also a serial entrepreneur who successfully built and sold a software and consulting company in the process manufacturing industry. And this is an award-winning software that was developed for operational excellence in data analysis, and it far-reached to over 300 customers. Vibhu, we are truly honored to have you participate in our event, and I'm passing over to you so that you can share a little bit more about yourself and your company and start the presentation.
Great. Thank you, Bianca, for the introduction. I hope you can hear me and see me okay.
Yes, I do.
Great. What I'll do is share my screen so I can cover some of the topics. All right. Can you see my screen okay?
Yes.
Okay.
It's visible.
So thank you for the introduction. It's a real pleasure to be here today and talk about one of my favorite topics, which is how technology is playing such a key part in the world today in every aspect. In fact, this conference would not be possible without technology. And I'm sitting here in Houston, Texas, and I'm able to connect with people in San Miguel de Allende, which is great. One day I wish to visit San Miguel. I heard it's a beautiful city, so hopefully I can come and visit soon. But this interaction is possible mainly because of the technology that's available to us. So a little bit about my background. I am a chemical engineer by profession. I actually grew up in India and moved here to the United States about 25 years back for my education, and then started working, started my own company, sold my company, started another company, all around the technology and digital transformation space. So this is a topic that I'm passionate about, and what I was hoping to do is to share some thoughts and trends about what we see in the industrial segment, which is manufacturing, chemicals, refining, those kind of industries, and also a little bit about some of the other industries which have been impacted by technology in a good way. So what is digital transformation? There are many terms used to explain this, and you'll hear that in different marketing campaigns about what it stands for. You'll hear Industrial 4.0, which is the fourth revolution in the industry. I'll talk about that a little bit later. It talks about IIoT or IoT. IoT stands for Internet of Things, where everything using Wi-Fi and Internet can be enhanced or deployed, such as Zoom communication. There's another term that's used quite often, which is called IIoT. And IIoT means Industrial Internet of Things. So these are things that are internet driven or cloud driven that have an impact in the industrial segment, right? But within digital transformation, there are two components of it. One is called digitization and the other is called digitalization. Okay, so there's a slight difference between those two. Digitization means essentially you're taking something that's analog, that's a hard copy, and you're converting that into a digital format. So the best example about that is, let's say you have a booklet or a manual about a certain a piece of equipment. That is usually available as a hard copy that you have to go to a room, either in the house or in your facility, go through that manual page by page, and then find out your information. That whole content can be converted into a software or a computer or a cloud form, which is called digitization. So today, if you buy a new phone or a new camera, you will get instructions on how to use it or how to program it, all on the internet. So either you download an app on your phone or you go to your computer and look into how you connect that or use that device, right? That process is called digitization. The second piece to it is a bit more advanced, which is the digitalization, okay? And in digitalization, it's where you're using digital technologies to change the way you do business, to change the way you operate, okay? And that can have a big impact on the revenue stream. It changes the way you've been operating, right? And I'll give you some of those examples from an industrial standpoint and what impact it may have. So first of all, data. You are seeing data and information everywhere in every aspect. People get hundreds of text messages. There's Instagram, there's WhatsApp, there's text messaging, there's phone calls. All this is collecting data, right? So every single day, we are creating, as humans, 2.5 quintillion bytes of data. And this year, it's estimated that we would be creating 2 MB, 2 megabytes of data every second for every person on Earth. So you can imagine the tremendous amount of data that is being generated and stored either on the Amazon servers or your phones or your computers or somewhere else. Now, the very interesting fact is all this data is also being collected for the industrial sector. So if you have a pump or you have a pipe or you have any other piece of equipment, all data is being collected about the temperature, the pressure, all the other variables related to that equipment, right? Now, the reality is that today, companies are only using maybe 1% of that data to make smart decisions. That means 99% of this data that's being collected by companies is just being dumped or stored somewhere and no one has any idea what to do with it. Now, if with the advancement of technologies, if you could process or analyze more of that data, you can make much more smarter decisions about how your process is running. So that's why data processing, memory, storage, all these things have become data analytics, all these things have become critical with the objective that all this data that we are collecting using data analytics and other smart tools, you can start using that data for useful decisions. Now, one thing I wanted to talk about is there are so many digital technologies everywhere in every industry, but there has been a focus by some leading consulting groups to identify 5 of the key areas where digital technologies can be transformative, okay? So if companies were to invest their money in digital technology or digital transformation, which are the areas they should invest in, right? So these are the 5 areas where people said they were going to invest their money. One of which is in the digitalization piece, which is the Internet of Things and data processing. I talked about that just a few minutes back. Then digitalization related to mobility or cloud. Let me give you a simple example. Most companies had individual desktop computers or maybe laptops for each employee in the company, and lots of different servers where all that data for that company or for that organization was being stored. What has happened now in the last 5 years is with cloud storage or cloud capability, all that data now gets stored remotely on Amazon servers or Microsoft Azure or Oracle Cloud or Google Cloud and so on. And so a lot of information has moved to that kind of remote storage, and you don't need so much hardware in your organization anymore because all that data can be pushed into the cloud, okay? The third area that was identified is machine learning and artificial intelligence. So I'll be talking a little bit more about AI and machine learning and what impact it can have, okay? The other area is automation and robotics. So I assume all of you are familiar with Tesla. One of the key things that makes Tesla more advanced as an auto company is that a lot of their manufacturing happens with robots. It's a very automated facility where very few people are actually working, and most of the tasks towards building those cars are done by robots. And that is a way for them to become more efficient and smarter and lesser errors, okay? Smart machines or smart infrastructure is another thing. Now the United States is trying to focus on spending a lot of money in building the infrastructure, which is not just roads, but it also includes providing broadband or high-speed internet access across entire United States so that everyone can get access to information and smarter machines everywhere, okay? And the fifth area was simulation, virtual reality or augmented reality, and what impact that can have. So I'm going to talk about that a little bit more. Bianca, I want to make sure you can still hear me and there's no problem.
Yes, Vibhu, I hear you, and it's okay.
Great.
Vibhu, we have received a question on the chat. Maybe you'd like to take a look before you move on. I see here that they ask, we talk a lot about data privacy nowadays. What would be the real disadvantages or risks of sharing information? I mean, sharing in popular channels like Facebook, WhatsApp, etc.
Yeah, that's a good question, and it is a challenge. Cybersecurity is a big issue, both for personal reasons as well as industrial information. There are a lot of apps and credit cards that are also available as an app on your phone, and if you share your password or somehow someone hacks into your phone, and that access becomes available to someone else, they can go in and use your credit card or use your cash in the bank and so on and so forth. So social media sites like Facebook and Instagram and WhatsApp can be dangerous. Just last week, Facebook had a data leak for 500 million of its users, where user data and personal information of up to 500 million people was leaked. And nobody knows how it happened, how they got hacked into, and what information they stole. But it's a definite problem. Password protection is key. Not storing all your information in one place is also critical. And so that's where companies, industrial organizations have come up with a model that's called an edge or a hybrid model. And I think I have a couple of slides that I will cover a little bit ahead that talk about how that data is managed so that you can take advantage of the cloud capability. At the same time, you can protect critical data within your organization or your personal data as well, right? So I'll talk about that a little bit more in about 2-3 slides. So one other piece I wanted to cover here was the 5 areas where digital transformation is having a big impact in the industrial segment. So one of which I hope the font is big enough to see is in the automotive space. You're seeing huge changes with electric vehicles, with smarter cars. Cars have now just become smart computers with wheels on them, where a lot of things like braking, like cruise control, lane changing, tire pressure monitoring, all these things have become computer driven, have become smart software that are detecting all these things while you are operating your car, right? In the construction area, a lot of these technology improvements allow you to track the building energy, have sensors everywhere, use drones to track construction and so on and so forth. So these are technologies that have had big impact in the construction industry. Agriculture is another area where there's been a big impact, and I'll talk about agriculture a little bit later. Healthcare, and of course, manufacturing. Okay, so this section is diving a little bit deeper into automation and digital solutions for industrial facilities. Now, I don't know how many of the participants come from the industrial segment, but I'll try and explain it in a simpler way, which is whenever you have an industrial facility like a chemical plant or a semiconductor manufacturing plant or an automobile plant. I know Mexico is very strong in the auto manufacturing industry. So that's an example of an industrial facility. There is a model that's used to describe automation in an industrial facility, which is called the Purdue reference model. Okay, and it shows 5 levels of or 5 layers in such a facility and what each of those layers mean. So the first layer, or the level 0, 6 layers actually, but level 0 is at the ground. So if you have an auto plant, then your actual equipment, your machinery, all of those things will be at level 0. In a chemical plant, for example, you would have a pump or a piece of pipe or a tank, and these would be at level 0, which are equipment installed in the plant. Okay. The next level is where you have some kind of sensor or some kind of controller to measure the value coming out of the pump. So if you look at a simple pump, whether it's a water pump or some other pump that you would have in your house, you will see that it will have simple measurement, which will track what is the flow coming from the pump, what is the pressure coming from the pump, and so on. Those values are tracked using instrumentation, flow meters or temperature indicators, and so on. That is level 1, which is measuring this kind of information. Okay. The next level is where you have some kind of automation related to that particular piece of equipment. Okay. Simple example is in your home when you have an automatic temperature controller for your air conditioning unit, right? You have that thermostat, and that thermostat is a very basic level of automation that you can get for a house or for a facility, right? But in industrial facilities and chemical plants and so on, you would have smarter controllers that would make sure that the temperature or the flow coming out of the pump is the same value every time by adjusting the opening, by adjusting the pressure, and so on and so forth. That is level 2. Okay. Level 3 enhances it further into a more advanced control over the entire section of the facility, not just one piece of equipment. That's what that is. Then level 4 is at a higher plant level where you have smart software that's continuously keeping track of the plant. The things like ERP, which is the enterprise resource planning software like SAP and Oracle and Microsoft that helps control, do things like send out invoicing, do things like order parts when your inventory is really low and so on. These are the things that are level 4, which are at a higher decision-making level. And then level 5 is where you have even higher level systems where information is going to the management of the company. Things like, what is my overall profit? How much is my cost for fuel? How much am I producing? How much energy is there? So on and so forth. So that's the higher the level goes, the smarter the system becomes. Okay, that more and more information technology, IT, smart systems, and digital technology becomes applicable. Yeah. So speaking of which, let me talk a little bit more about what is a digital twin. Okay, so a digital twin is essentially a virtual copy of an industrial asset. If you had, let me explain to you, like if you have a car, right? You have an actual car, and I made a copy of your car on the computer. You can see the doors, you can see the color, you can see your seats, you can see all the functions. That is a virtual replica of your car. Same way, when I capture all the components of my industrial asset into my software, that makes it a virtual copy of the industrial asset. And it's like a twin, right? It's a copy. It's identical. What it does is it takes all the key equipment, it takes all the key processes, steps, procedures, information about that asset and puts it all in a software format so that you can do all kinds of analysis, you can collect the data about the asset, you can process that data, and you can make smart decisions with it, right? The more data you have, the more analysis you can do and the smarter decisions you can make, okay? So the image that you see up is an example of how you can take an actual industrial plant and capture all that information and then start tracking how that asset is performing, okay? A lot of powerful things that you can do once you have that. Now, one very interesting fact is that more than 70% of industrial facilities have still not digitized their assets. They still depend on hard copies or information from one individual in that facility who knows everything about running that. So there might be a pump expert, and that is that one person in the organization that knows everything about the pump. So if that one person becomes unavailable or retires or leaves the company, then all that information goes with him. Nobody else in the company knows how to run that pump, right? And that's a real problem with all the last 20 years of work that me and my company have done for different organizations. This is a huge problem where that information is not captured digitally and can get easily lost. All that knowledge can go away. So it's called the knowledge drain or the brain drain, where if that person leaves the organization, all his knowledge, experience, and expertise goes with him because it was not captured digitally, right? Another big advantage is that information about these industrial facilities stays with different groups or different individuals, right? Just like I talked about the person who has knowledge about his equipment, all his information might be on his computer. So if he's done any lab analysis, the lab data might be here. Maybe he has an Excel file with information or a Word document with the manual all that might be in separate locations, and the rest of the people in the company have no access to it or no knowledge of it. When you create a digital twin, you are essentially capturing all this information in one place, and you can access all that information from that same location, and everyone can access that same information. So it's called standardization of data. So you have one source of getting your information. You're not looking at some old file somewhere. You're not having to call somebody and ask for that information and not know whether that information is correct or old, right? So those are some of the advantages of having a system like this. So I had talked about, I think, Bianca, one of the questions that the audience asked was, how do you protect data from being stolen, and how do you manage and maintain that information? This chart will hopefully explain that properly. There are 3 levels from edge and cloud computing, right? So here at the bottom, you see actual sensors and actual equipment where that information is being collected, like what's the flow coming out of the pump, or what is the temperature, or what is the fuel capacity, and so on. Then there are edge devices that what it means is that using internet connection, these devices are located in your facility and they're collecting that data. They're collecting that data and they're making some level of decisions, okay? Maybe they're making decisions like, should I turn the pump on, or should I turn the pump off, or should I increase the flow a little bit or not, right? Now that data can then be sent to the cloud. So let's say I have old data about how my plant performed in the last 1 month, right? I've collected that information here, but I don't need to keep storing old data. What I can then do is I can push this information through the internet in the cloud, where I can store that information over 1 year and do other smarter calculations to develop trend of how my performance is going over a period of time, right? That action can happen in the cloud. And you, at this level, which is in your facility, you can still protect your data because that access is not openly available in the cloud and not everyone can access it. Here you can limit who accesses that information in your organization, okay? So that's an example of how companies are managing their data by taking advantage of cloud, but also keeping some critical data in, it's called on-site versus off-site. This would be the on-site part where you keep information on-site, okay? Little bit more about artificial intelligence. It's something, artificial intelligence, machine learning, data analytics is something that you may be hearing of every day. And for the younger people in the audience, this is the hottest area that they can get involved in for their future, for their careers, okay? Well, what is ML? ML is machine learning, and it's a subset of a concept called artificial intelligence, okay? In a way, when you want to make artificial intelligence happen, you use a technique called machine learning. It's a way where you provide more and more data in a consistent way so that a software program can use that data and learn from it. It develops a pattern. Once it develops a pattern, it can then recognize that pattern every time, and it can use that to predict or propose or forecast a pattern moving forward. That is how it becomes intelligent artificially. That's why the name artificial intelligence, okay? Data analytics is when you have all this information, all this data, and you use that to make smarter decisions, where first thing you need to do is you need to inspect this data to see if the data is accurate, it's come from the right source. You clean that data if there is some wrong information coming from it. And then there are many smart data processing or data analytics systems that can take that data and make predictions or patterns or allow you to make smart decisions. And I'll give you some examples of that as well.
Vibhu,
Yes.
I think this is related to one of the questions we received. We have a question here regarding intelligent power grids. So they want to know if you could comment on intelligent power grids. I mean, grids where power companies have access to consumer data in real time and are able to adjust set points in home appliances like lights, air conditioning, and even batteries to be adjusted to the balance the grid in real time as variable energy sources are connected to the grid.
Yeah, that's an example of smart infrastructure, and it's something that, frankly, the United States has been very slow at adapting. Some other countries in Europe have been a lot ahead of the game. Even Korea is far ahead of the game. What it is there are two parts to it from a smart grid perspective. One is within the home, okay? Within the home, you have smart devices such as Wi-Fi control devices where using a phone or using the Amazon Alexa device and so on, you can control when your fan turns on, when your light turns off, you can automatically turn it off or on. And you can also program your thermostat from your phone, where it can be made warmer or colder so that you consume less energy, right? So that's making your home a smart energy home. That's one way to do at the house level. And then when you go to the overall grid, again, there are two pieces, okay? One is you have smart meters in your house. These smart meters are digital meters, which are, see, all the older meters that are tracking your energy consumption were manual. So someone from the power company had to come to your house and measure the actual consumption and then go back and report that and send you a bill based on that, right? But now you have smart digital meters that automatically collect that information and send it to the power companies so they don't need to send anyone. That allows it to be more efficiently tracked, and they will know who's consuming more power or less power, right? The other aspect is that in a smart grid, you have power is generated from multiple sources. So a typical power company today will get power from many distributed networks, which is, it could be solar power, it could be wind power, it could be natural gas based power plant, it could be water based hydroelectric power, nuclear power, and so on, right? So having these discrete grids connected allows a smart grid infrastructure to know which of those grids are running at full capacity, which one has spare capacity. And so when there is a higher demand, like in summer, in peak summer, when there's a lot more demand for air conditioning, it can decide which of those power sources have higher capacity and make those available. Plus, in a smart grid, you have the distribution, right? All the power lines that you see everywhere. There are a lot of losses and down time on those power lines. And these smart grids, these are sensors all throughout your power line, your distribution network, that can track and see what losses are coming from your distribution lines and which lines are down that need to be repaired quickly so that you don't have loss of power to the consumer, okay? So that's the whole concept of a smart grid.
Okay. Also, we have another request. Please comment about the differences and trade-offs of models based only on statistical analysis of data and deterministic mathematical models.
Can you repeat that question with reference to what? To industrial data analytics?
Yeah, sure. Please comment about the differences and trade-offs models based only on statistical analysis of data and deterministic mathematical models.
Okay, all right. So when you have data coming in, let's say you've collected last 6 months of data on how my pump operates in my industrial facility, you can analyze that data using simple statistical models, median averages, sequential programming, logarithmic. You develop a trend or a chart, which essentially once you have 500 points on an Excel chart, you can draw a trend line which uses linear interpolation or uses second degree polynomial trend lines and comes up with a model based on that. That's typically a lower quality model. It's not as accurate or as advanced as a physical model or physics-based model. A physics-based model is essentially based on first principles of engineering, and it honors the principles around modeling and around engineering. And using those principles, these models, these are typically process modeling tools or simulation tools that use this rigorous physics and thermodynamics and chemistry and take that same data and come up with solutions that are based on first principles engineering. Those are considered high fidelity, fundamental or rigorous models, and they give you a far more accurate output or prediction for the same type of data, okay? And so that is the difference. But as you can imagine, simple statistical models or Excel charts or trends, they're very easy to do, very quick to do. And sometimes when you just need an approximate answer, those are good enough, right? But when you're working in an industrial facility where a lot of complex information is there, these simple models are not adequate. And also, small changes in industrial facilities, even a 0.1, 0.2% improvement or change can either give you millions of dollars in benefits, or if you have a wrong model using just statistics, you could lose millions of dollars because you made the wrong guess. So you cannot guess in these facilities. You need to know exactly what is happening. And that can only happen by using these rigorous physics or engineering-based models and not simple statistical models. So that is the difference and the trade-off. Depending on what you're trying to do and how much data you have available, you can use either a simple trend statistical model, or you can use a complex engineering-based physical model, okay? Bianca, one quick question. You said there is more time available, so I'm going into more detail. If you want me to speed up and finish sooner, I can do that too. What is your recommendation?
No, please take your time, go on your own pace. And actually, I have one more question, if you allow me. This is from myself. We have smart grids technology around for a while now, and I would like to know from you, what do you think is the most the main barriers for us not having this implemented widely?
Is this for power in particular or anything?
Power in particular, but it could extend to other fields.
Okay. I think one of the problem is that the distribution network is very, very old, particularly in the United States. So one of the problems is the funding and the political will in the country, which is in order to upgrade the infrastructure, you need a huge amount of investment, hundreds of billions of dollars to make it smarter. Just a simple example, if you want to change your analog meter in your house into a digital meter, that cost can be $1,000. So most homes are not going to choose that solution. They would prefer to stay analog and not spend that kind of money to get a digital meter. That's just your house. If you need to change your, while the technology is available, right? But similar cost to make your grid smarter is, entire distribution network smarter is a huge amount of money. Plus building facilities like power plants can also cost billions of dollars. And that's why in the US, for example, the power resources are not enough to meet the increased population and the increased consumption of power. The population consumption of energy has gone up 10 times in the last 20, 30 years, but our power network is the same. So that's why you see in summer in many parts of the country and even globally, there are power trips or power failures where you lose power for a period of time and there is peak demand. Okay, so solution is known, answer is available, but if funding is not there and if the local or state or federal governments don't implement policies, then things don't get resolved, unfortunately. So hopefully that answered the question. I'll continue forward. Again, this is for the younger people in the audience. I thought I will throw this information in, which is if you want to be one of the people that implements AI and machine learning technology, these are the 5 most popular, most in-demand programs. And all the companies that you see out there that play in the artificial intelligence space, they use these 5 languages to program or to make those machines process the data, okay? So Python is the most popular one. Even my team uses Python to develop artificial intelligence and machine learning for plant data, for facility data that we collect. R is another one that's very popular. It is more statistical driven. So it can take that data and do statistical processing very quickly. And it's a very popular tool. Java is something, of course, that's used quite a bit for computation and parallel processing and so on, and visualization as well. And Scala and Rust are the 2 other languages that have become more and more popular, okay? So if you feel like, hey, artificial intelligence, machine learning, that's where you want to be, then you need to be knowing one of these 5 languages to make it happen. Now, this was in response to one of the questions that was asked earlier, physical models versus statistical models, right? So what you'll see a lot of companies promote that artificial intelligence can solve all the problems, right? Well, that's not true because artificial intelligence by itself cannot solve complex problems. What we believe is the best way to do it is use a combination of physical models, which are engineering-based fundamental models, combine that with statistical models or data analytics, and that's how you make a really smart model that can take advantage of both of those to give you the best decisions possible, okay? So engineering models combined with data analytics and machine learning is the way that you can get the best solutions. So a couple of industrial examples that I will share where statistical analysis was very powerful, right? Valve and pump analytics. So we had a company that was having a lot of troubles with pump performance, pump energy consumption, and the valves that turn on and off in order to make flow go through a pipeline were either getting stuck or needed repair or needed replacement. But the company did not know when to replace them or which valve was stuck and where repair was needed and so on. So we collected 6 months of data for both the pumps and the valves. And based on that data, we ran statistical models using data analytics. And we were able to predict that every 6 or 7 weeks, some valves were getting stuck because it was getting dirty or it was getting clogged. And those needed to be taken off every 6 weeks, cleaned up quickly, and put back online without damaging the operation, right? Same way with the pumps. There were some pumps that were getting clogged because it was pumping dirty fluid. And we could predict accurately when those pumps needed to be cleaned up or changed, or when they might need repair. And that saved the company hundreds of thousands of dollars simply by collecting 6 months of data and using these data analytic machine learning models to start predicting based on the pattern of the last 6 months, predict how the valve and pump would perform in the future. Okay. Another example, a more complex example, is a chemical reactor performance of that. Here we used a combination of physical models where we built an engineering-based model of the reactor so we could predict what chemical reactions were taking place and what temperature to expect, what flow to expect, what pressure to expect. But we also combined it with machine learning so that we could predict when some things or some properties of that product that could not be easily calculated unless you did a detailed lab analysis, right? So sometimes if the color was off or some other performance issue was there that you can only find out 8 hours later in a lab result, you could use data analytics to predict that information while the product was being made instead of 8 hours after the product was made. So that's an example of an industry where data analytics was used. So how does digital twin work? A few steps to making it successful and for implementing. First step is you have to collect data. And that data needs to go to a simulation model or a statistical model or a data analytics model or one of these programming software, right? One important point I will make here is that it's very important to make sure that the quality of the data is very high. There is a saying in our industrial world that garbage in, garbage out. It also reflects here where if the quality of your data is really bad, then any output or any model is also going to give out garbage results out of it. That means those results have no value because the system can only be as smart as the data that comes in, okay? It cannot make smart decisions if the data is bad. So that's an important part to make sure you give good quality data to it. And whether you run a simulation or statistical model, you generate the results, you compare that. So you compare, for example, how your pump is performing, what it is flowing, what temperature, what pressure, and you compare it against what the model says it should do. Based on the design of the pump or the capacity or the operation of the pump, it should produce so much flow at such and such a temperature, at such and such a pressure. So you can compare that value versus the actual value. So take, for example, if you have a dishwasher or a dryer or an air conditioning unit, your air conditioning unit is supposed to consume so much energy and it's supposed to convert, bring the house down to such and such a temperature in so much time. If it's not doing that, that means there is something wrong and you can compare and you can try and fix it, okay? That's the next step. And then by doing this on a continuous basis, you can constantly keep trying to monitor how it's performing and continuously trying to improve how it is performing, okay? So that is the benefit and setup of a digital twin. Okay, so this part is going into more about how you can use new technologies like virtual reality and augmented reality, which are known as VR and AR, and how that can have a big impact in construction, in the chemical industry, in safety, in training, and all these different things, okay? So I found a good video from a chemical plant, a small lab scale chemical plant that shows how you can use virtual reality to help people understand that facility and to learn more about it, okay? So I'm going to try and play it. Hopefully it comes through okay. So this showed how you can go into a plant or a facility, turn the valve on, turn the flow on, and then remotely control it from a computer. That's one real example of how virtual reality can be used, and it's pretty powerful. Another example I have in my next slide, this piece is about augmented reality and what the differences between the two are. I'll cover that in a little bit. But this is the augmented reality example. You know, Facebook now sells a device where you can play video games and do car racing and whatnot wearing the Facebook lens. Microsoft has a product like that as well called HoloLens. Google has a product like that where you can do interactive gaming and so on. Well, the same thing has industrial applications as well. So I'm going to run this video and give you an example how Chevron, which is a very large oil company, how they use augmented reality in industry.
This is a technology that is going to take us to kind of the next level of digitization. Chevron uses Dynamics 365 Remote Assist for two core scenarios. The first one being remote expert, where we put any expert anywhere in the world in under a minute. And the other one being remote inspection, where we allow our inspectors to inspect the construction and the operations of our facility in real time. We have facilities all over the globe. We have facilities in areas that we can't get to all the time. So being able to digitally transform that expert into the field within a minute or so is foundational and just transformative.
This saves our engineers and our folks tons of time in how they go about doing their normal work every single day. That's a tremendous reduction in operating expense for us as a refinery, but also it makes their job a whole lot easier.
It's critical that the team's able to innovate and change. That's really what gives us the competitive advantage against other refineries.
Out-of-box solutions are important to Chevron because we simply don't have the expertise to build those solutions and maintain them long-term. We're not a software company. We're not going to do it as well as a Microsoft would. And it's just not cost efficient for us in the long term. We've acquired over 100 HoloLenses. It's another device just like our laptops and our phones. And we hope to get to thousands of HoloLenses. From a Chevron perspective, the HoloLens is just a brand new technology that's enabling us to do things that we couldn't do in the past.
So that's an example of how, while you can play video games and do car racing, you can also use it to save millions of dollars in a company environment, okay? But VR and AR are slightly different. VR actually replaces the reality. It allows you to remotely learn about a facility without actually being there. And AR actually adds to that reality where it gives you additional information that allows you to make smarter decisions, okay? So IIoT devices, I talked about this. There have been a lot of advances, both for smart grid as well as in industrial areas, oil and gas, chemical plants, airports, and whatnot, where you have sensors, both indoor, regional, and global sensors. So you can track where a ship is, when the ship is going to get to the dock, or remotely track facilities using these kind of sensors. Just like your home Wi-Fi network that you're using right now to listen to this presentation, that is only available indoor, but you have smart devices now that can track through satellites and through towers as many as 200 miles or 2,000 miles or anywhere in the globe using high performance satellites, okay? That's what these IIoT devices are. I'll talk a few minutes about different areas where digital technology has been implemented to save money and improve safety in a whole different range of areas, okay? One of which is climate change. Climate change obviously is a big issue that we have to address and to resolve. And it results from greenhouse gas emissions, which cause the change in temperature. And GHG, as it's known, you need to be able to track it, avoid losses, and be able to reduce those emissions in order to stop climate change, right? So there are technologies available now like drones, like airplanes and satellites that can take 4K, 8K, very, very high quality images from high up in the sky, like this company called GHG-SAT. They can take these pictures from airplanes or from satellites, and they have software that can track if they detected any kind of emission or a flare coming out of a pipeline or a facility, and they can go and quickly find a way to stop that leak or to stop that loss, right? There are other tools like these high-end cameras that are available in the plant, in the chemical facility, that's constantly measuring. It's like your home safety camera, right? It can detect motion. It can detect, these smart devices can not only detect motion, but they can also, using laser technology, detect any chemicals. So if there's a chemical presence of any kind, it can collect that data, take a picture and send it to a computer or send it to the environmental people so they can come out and fix that leak, okay? All this is because of digital technology. Same way in supply chain, there has been a big impact using supply chain technologies to be able to predict exactly where your material is, when it's going to be manufactured, when it will be available in the warehouse, and how long will it take to ship it out. The most excellent example of this is Amazon, where if you use the Amazon Prime or the Amazon delivery facility, when you place an order from your computer or through Alexa, you know exactly how and when your product is going to come, where it is, when it was shipped, when it got into a truck, and when it's going to come to your house, right? All that is because the entire supply chain is digitized, and you can track all of this information. Same way in agriculture, which is a huge part of energy consumption as well as economy, both in Mexico, in the US, and countries like India, where 70% of the economy is based on agriculture. It's a huge consumer of resources as well, like water and soil and feed, pesticides, and so on and so forth. Losing a crop or not getting an efficient crop or using too much water, all these things can have a big impact on food being available, as well as food not getting spoiled or destroyed, right? So again, you can use drones, you can use sensors to track irrigation, how much water is being consumed. You can use efficient supply chain to track once your crop is produced, how quickly can you put it on a truck and ship it out to the grocery store, right? And so on and so forth. So big impact in agricultural space. Medicine. I think the last 1 year, because of COVID, you've seen a huge impact of how technology allowed these companies to come up with a vaccine. They used a lot of artificial intelligence to come up with the right formula for the vaccine, quickly produce that vaccine, and quickly ship that vaccine to all the hospitals and pharmacies, right, to be deployed. But telemedicine is a huge area where analytics was used, where there are interesting stories of if you take a picture, let's say you have an infection on your hand and your hand is red or it's itchy, you can take a picture of that, submit it on the site, and you'll have smart experts, skin experts, dermatologists that would look at that and tell you the remedy or the solution for it based on their experience, right? It's very interesting. Same way telemedicine, you can remotely talk to your doctor and explain what your problem is, and the doctor can diagnose you and prescribe the medicine, which can be sent to the pharmacy, and Amazon can deliver it for you. So that's the advantage of how technology has made this sort of world and these systems very accessible. A lot of people have asked about blockchain and digital currency and Digicoin and all of those things, cryptocurrency. Those are things that I would advise everybody to stay away from right now, because it's very speculative. The technology is very, very nascent. It's very early. Well, what it essentially means is that it uses blocks, which are records, right? A record or an information about a transaction is called a block, and it is secured by cryptography. So there is like a software code that locks that data and makes it private. And when there are blocks and blocks of this kind of data, it forms a chain of information, and that is then known as blockchain. Okay, so it's an open network, it's a distributed network, no one person controls it, it's permanent, but it's also exposed to software, it's also exposed to computers, which can go wrong, it's also exposed to access and depends on things like internet connection, the cryptography should work, the locking mechanism should work, and that all is not very secure right now. Unless the governments back it and endorse it, it's not something where you should be putting any of your money. I think I talked about this as well already. This question was raised where cybersecurity is a big factor and something that you really need to be careful about. Okay? Well, I'll tell you one interesting story based on this joke that's here in the slide. Is 80% of the hacking or stealing of information comes from people that forget to put a password on their computer, or they have all the password or information on a USB drive and they don't lock it, or they leave that USB drive, or they forget their company ID, a company card somewhere that someone can take that and go into the facility and access the information. So very few of these data breaches have occurred because something was wrong with the security network. But usually the individual human error that did something silly to lose that access. Okay. Now, this opportunity for data analytics, digital transformation, industrial automation is huge. Every company is moving in that direction to become smarter and use and digitally transform themselves. It's expected that this business would be as big as over $300 billion over the next 5 years, and it's growing very, very rapidly. And since most of our audience is from Mexico, it's a great opportunity for people in Mexico because it's a huge market. It's very close to the North American market. It's a big manufacturing and agricultural base, and so having the knowledge of artificial intelligence and digital transformation will truly benefit people in Mexico. One other area where digital transformation is very valuable is human capital management, which is for training and improving one's capabilities and knowledge. One thing you saw that e-learning and online courses became hugely popular in the last 1 year because you could take courses from Harvard or you could take courses from other big universities sitting in your house. You could get e-learning, you can interact with professors, other people participating in the class, and that really changed the way education is happening in the world. But one key thing is you can take advantage of virtual reality models. You can take advantage of all the content being available virtually and learn from that aspect, right? So it's called the see, hear, and do model, which is you can, when you see something, you get certain level of knowledge. When you hear about it, you learn more. But when you actually do it by virtually operating it or by doing a simulation or by going through the course, that's when you learn the most about that topic. And digital technology is what makes that happen. So to summarize, this is game changing. It is going to impact every aspect of our life. One thing I like to share is that my father, for example, is 84 years old now, and he never used any of these technologies, computers or emails or any of this when he was working in the first 30, 40 years of his life. But in the last 3-4 years, he has been emailing, he's got WhatsApp, he uses Apple Music, he uses Alexa. and he joins Zoom calls to talk to me and to other people, right? So even at his age, technology has become a critical piece for life. And so that's why this is going to be game changing for everyone. And so better to join it than try to fight it, right? And this is just something that's evolving and it's going to grow exponentially. And so the best way is for you to join it and enjoy it instead of trying to fight it. So what I would like to leave you with is that in this new evolving world, in this new digital world, it's not how big you are. It's not the big fish that eats the small fish. It's the fast fish that eats the slow fish. And that means if you quickly adapt these new technologies and if you start using them effectively, you can get far ahead than anybody else who might not have access or might not embrace any of these technologies. Okay. So I will leave you with that. And here is my email address. If you have any questions or want to reach out to me, please feel free to email me and I will be more than happy to hear from you. But if there are any questions at this time that are still left, I would welcome them.
Okay. Thank you, Vibhu. We actually have one more question. Actually, we have a comment on the other topic we're talking about. Okay. It says, I would guess that with a smart grid, it would be possible to have distributed generation of power from every home, saving on the need to build big power plants. That's one comment that you received. And the question is, machine learning and ML and AI, the technologies that you mentioned, seem to be most suitable for manufacturing industry. How can I use AI to optimize a small business?
Well, depending on what the small business is, you could use it for different things. For example, the Amazon Alexa app, which responds to language, right? When you talk to it, it uses AI as well. It uses something called natural language processing, NLP. And the purpose is the more things you tell Alexa, that it stores it in a database. And when 100 million people are talking to Alexa, it's collecting all that data and becoming smarter about what questions people ask, what people are looking for, and things like that. Another interesting point is when you use your credit card or when you go to certain restaurants, the credit card company knows what kind of a shopper you are, where you shop, what you do. And based on that, it then predicts how much you're going to spend and what kind of things you're going to buy. When you go on Facebook, Facebook is using AI. So when you, on your computer, look for a car, Facebook will start showing those car ads the next time you go to Facebook because it has understood that maybe you're shopping to buy a car. So you'll start seeing ads from different places. So if you're a small business trying to promote your restaurant or you're trying to promote your printing shop or maybe you sell some devices or equipment for consumers, you can promote it on Facebook. You can advertise in different places. If you're making some handmade devices that you can sell, you can go to Etsy or you can go to other sites to sell those things, and Etsy will find out people that are in your neighborhood and promote it to those people who like those handmade devices, right? So there are so many ways in which AI can have an impact. It really depends on your business and what you're doing. And I'll comment on the other point about the smart grid. I actually just installed solar panels on my home. It was expensive, but there is some federal benefit I get from it. But the advantage is this, that I will generate my own power that I need to run my house. I don't need to depend on the outside grid. So that's one way more and more homes, as they become self-sufficient. In fact, if I generate extra power, extra solar power for my house, I can sell it back to the grid. So if I'm buying power at a certain price, if I make extra power, I can sell it back at the same price to the same grid that my neighbor can use. So yes, that's the interesting concept where it's going as more and more houses become self-sufficient. It can feed back to the same network. Hopefully in the next 10 years, we'll see that kind of a seamless smart grid.
Yes, I hope so too. Vibhu, we have one more question just received. They say, I feel that companies have no difficulty in collecting data, but in how to extract value from this information. Any tips?
I would say two aspects, and I made that point before, is that there's so much data being collected by companies, but less than 1% of that is being used for anything useful. So just collecting data doesn't mean anything. What I would say is you identify a piece, a small part of what you want to do with that data. Let's say you focus on one part of your business, or you focus on one part of a chemical plant or something, and you use data to fix and solve that problem, okay? Once you solve that problem, then you can expand that to look at other things. And then you can become more and more smarter. Just like a smart grid, the whole grid is not going to become smart overnight. Small parts of it will become smart, and as it grows, it will become smarter and smarter. So what I would say is to not try and solve all the data and all the problems in one shot. Take a smaller piece of that data for a smaller problem, solve that first, and then start expanding based on that.
Okay, I think this is all. We don't have questions anymore. We can end for today. Okay, we didn't receive any more questions, so I'd like to thank you, Vibhu. It was very insightful, and I think it's crucial to foment this kind of discussion because regardless of the size of your business, or even if you are an independent worker or you work for a company, one thing is for sure, digital transformation is imperative. So if you don't want to be left behind or miss out on opportunities, you have to keep yourself up to date on these trends. And Vibhu, we really appreciate your contributions to our event, and I hope we can keep in touch. For everyone who joined today, thank you so much. The event goes up to Friday, same link at the same time every day. And please fill in the feedback form I have just sent in the chat. And for more information about the keynote speakers, please access our website, which is smartspacehub.com. Okay.
Please only say good things about me.
Of course.
Thank you everyone for your time. I enjoyed, and hopefully some of this was new or interesting and valuable to you. I appreciate the opportunity. Thank you.
We appreciate it as well. Thank you so much, Vibhu.
Bye.
Bye-bye.
也可以少